Thank you very much. First of all, I want to thank everybody for having me here at the conference, and thanks as well for everybody joining this track. So today I want to talk a little bit about service communication. I would say it's not only important for microservices, but in general, the more services you have in your company, the more important, good, and efficient communication becomes. So first of all, who am I? So I work at JobCloud in Zurich. We're one of the biggest job boards in Switzerland, and we have our development teams in Zurich and in Belgrade. I'm really into event-driven service architecture, and I'm a contributor to the PHP Kafka extension. Now, when I do find some spare time, I really like to cook, and even more so to eat. And I like to read a lot about new technologies. So what I will be covering in this talk, so first I will talk about how we can communicate with our services. So API communication, messaging, event streaming. And then I will go into a little bit more detail what this would look like in a real case scenario. And then at the very end, we'll see what are the takeaways of this talk. So first, API communication. I like to think of API communication as this dog. It has been a loyal friend for many years, and it's been really good working with it. So I think we can all agree that APIs are well known. I think many of us have probably written REST APIs or integrated REST APIs in our careers into our applications. So it's fair to say that APIs are well established, and I would even go so far to say it's really easy to integrate APIs into our services. When we talk about messaging, I like to think of messaging like this carrier pigeon here. So me as a developer, I don't need to know too much about other services. So basically what I can do is I can create my message. I can say who the receiver is, give my message to this pigeon, and it will deliver the message for me. So some of the things that messaging promises. Messaging promises loose coupling, meaning that we don't need to know too much about the other services that we need to communicate with. Messaging is asynchronous. Messaging also helps with service resilience. And I would also say it's easy to integrate. Maybe at first, if you're used to integrating your services over API, it might be a little change also in technology, but I would say once you have running services that can communicate over messaging, it's really easy to integrate more services to use a messaging concept. So what about event streaming? What exactly is event streaming? Basically, event streaming uses a lot of the messaging patterns as well, but it differs a little bit in the end result. So for me personally, I think with event streaming, we can actually achieve decoupling of services. So you don't need to know anything about the services that you are communicating with. Since event streaming is also based on messages, it is also asynchronous. And important advantages of event streaming, especially in the case of Apache Kafka, is that you can replay your events, and it really has a plug and play kind of spirit. So, but what does this now all mean? How would this look like if I use any of those three means of communication in my services? So I want to show a little example how it would look like for each of these means of communication. Small disclaimer beforehand. So maybe the service architecture of my service that I created here is not perfect, but it is more important to see how communication looks different in each use case. So let's say we have a web shop, so we have a front end, and then behind in the back end we have an order service which coordinates other things around the service, and we have a warehouse service that is in charge of handling the inventory, and a shipping service to create tracking numbers for your orders that will be shipped out. So now if a user comes along and places an order, what would happen in an API case is it would make an API call to the order service. Now the next step might be not the best, but for this example, let's say the order service would not immediately reply back to the front end that it received the order, but behind the scenes would call the warehouse service to book out the ordered items out of inventory, would make an API call to the shipping service to already get a tracking number for the order, and then at the end of this chain would reply to the front end and would say, hey, I received your order, it's being processed, and we already have a tracking number for you that you can open and follow in a few hours to see where it will be. There's one problem when we're using APIs, it's that APIs are synchronous, meaning that if the order service would be down, this would all not be possible. So in the worst case, when our user tries to place his order, he will be presented with an error message saying, okay, we're really sorry, something went wrong. And then with the best, I think we all love this error message, please try again in a few minutes or in a few hours. Now, if we're really lucky, this only happened because of an unstable network connection. And when he retries, he will be able to place his order. But if our order service is really down, this might be really, really frustrating for our user. And he probably will go on to another web shop and order his items there. So how would this be different if we use a messaging approach? So first of all, a little bit more about messaging. So in traditional messaging services, you will have an application that will act as a sender, and it will send out messages to a messaging component like RabbitMQ, like SQS. And then you will have a receiver reading that message. So it will pull out the message of the messaging queue. And once the service is done processing that message, it will acknowledge that message, and the message will disappear from the messaging queue. So if we take the existing example from before, so I split all the services into a sender group on the left, where we have all the services from before, and also acting as receiver on the right. So if we play through our example from before, our user would still come along, and from the front end would order some products. And the front end would send a message to the messaging service, and the order service will then pull that message from there and will process that message and will say, okay, accepted the order. And next, the order service would then create some messages on its own. I would say the order service would probably create up to 3 messages. First message would be back to the front end, would say, okay, we accepted your order. Second message would be to the warehouse service, where we say, you need to book out some of these products that were just bought out of inventory. And the third message would be for the shipping service saying, hey, we have an order that just arrived. Please also create a tracking number for this order. And then we would move on. Same again, once the warehouse service has received that message and has processed that message, would probably send out, again, 2 messages on its own, would send out a message to the front end, maybe saying, okay, we moved your order from accepted to processing. We're gathering your items and everything. And would also send out a message to the order service, since the order service is like the orchestrator in this scenario and needs to know what is the exact state right now of the order. And then last but not least, we would have the shipping service that also received a message and would again also send out a message to other services, would send out a message to the front end saying, okay, here's the tracking number for your order, and same again to the order service, so the order service can track what is the current state of this order. So now, if we kept count of all these messages, we can see that in total 8 messages were sent around. So how would this now look different in a streaming approach? So first of all, the difference in a streaming approach would be a message is not intended for a receiver. Basically, when you're using an event streaming approach, your application doesn't care what other services are around. Your application will simply send out events, and everybody who's interested in those events can actually listen to those events. So if we take our example from before, it would look a little bit different. So when we get the order from the user, our front end would create a message, but with no receiver intended. It will just broadcast the message and say, okay, I received this order. And then all the services that are interested in those kind of events can actually sort of plug in and listen to that message. In our case, it would be the order service that is interested in new orders arriving. Now, once the order service has received that message and has transformed it, it will send out an event on its own. And it will say, okay, I've accepted an order, and send out the new event for this accepted order. Now we have 3 services that would be interested in listening to that kind of message. As we saw in the example before, this would be the front end, the shipping service, and the warehouse that would be interested in the message that we have received a new order. Then it continues in the same way. So the warehouse service again would do the same thing and would book out all the products of the inventory and would send out a message saying, okay, I booked all the products out of inventory, and front end and order service can track that message. And then last but not least, shipping service as well will send out a message saying, okay, for this order, I created a tracking number, and again, front end and order service would be interested in that. So if we counted the messages here, we can see that we only send out 4 messages. Now before in the pure messaging example, we send out 8 messages, so this is 4 messages less. Now we might say 4 messages less is not a lot, but when you factor in this is a really small use case, and in your company you might have a lot more of services, you might have hundreds of services, and then when you can cut the messages in half, I think you can really profit, because if you communicate well, it's important to keep other factors in mind as well. So latency could be better if you don't have tons and tons of messages that you don't need. Also, cost might be a factor that's important for you. So I think it's really cool to communicate in a good and efficient way between your services. So, but what is the conclusion here? So first of all, what's really important, I think a lot of traditional messaging services, the spirit of them is point to point. So we have an application on the left side that will act as a sender, and it will send out some messages to a messaging queue. But as we discussed before, the message is always intended for a receiver. So if we have multiple receivers that are interested in a message, we need to send out more messages. This is why it's only loose coupling. So we don't need to know anything about the other services, but we need to know how many receivers we have. So to whom to address the messages to, or how many messages at least we need to send out. Now, as we saw before, in a streaming approach, this looks very different. A streaming approach is more publish and subscribe. So in the example, if we would be taking Apache Kafka, we would have an application again, as we saw before, on the left side that would act as a sender, but it would only send out one message to an Apache Kafka topic. And then the great thing is, we don't need to care about anything else. The only thing that this application needs to be able to do is send out its message to this topic. And then the rest is up to other applications. Every application that is interested in those kind of events can just plug into that topic and listen to these events. And the cool thing is, since we don't have a receiver for it, all applications can receive those events that listen to that topic. And I think this is the real benefit here in event streaming. So you just need to send out one message and you can read it 50 times, 100 times, how many times you want for all the applications that need that kind of data. Then in special, when we talk about Apache Kafka, I think there are a lot of other use cases that also make event streaming a really strong way of communication. I want to take Job Cloud as an example. So as I said before, Job Cloud is a job board. So we have, let's say, a search index which index all the job ads that are online. Now let's say our search index crashes for some sort of reason and we don't have a backup. But since we have events for all the job ads that need to go online, what we can do to rebuild the search index is we can just reread all the events of the job ads that need to go online. And I think this is a really cool way to have stable services. Same thing goes for what if we take the example of the web shop again? What if we made a deployment to the warehouse service and for some reason we introduced a bug? We all know this can happen. Now let's say because of this bug, the warehouse service will not book out products anymore. So once we notice this, what we can do is we can fix the bug on the warehouse service and deploy it again. And then the great thing is we can say, okay, please read all the messages again since when we introduced that bug. So we can repair our inventory and book out all the products that weren't booked out before because of the bug that we introduced. And then last but not least, I think it's also really great for debugging things. So when I think about me developing services and they're communicating through API with each other, if I take the web shop example again, if I want to test the whole flow and I'm using Docker as for each of the services, I might need to spin up every of these services to track a bug that is happening between those services. I'm not sure, is it because of API communication or because of the server itself? Now, when we think about messaging, the only thing that I need to be able to do is to generate messages that these services will send out. So I can only spin up one service and emulate all the calls through these messages and debug my service and find what could be causing a problem. And I think this makes us overall really flexible, and this makes event streaming a really great technology to use in applications. So, but there's no really right or wrong. So it doesn't matter if you're using APIs, it doesn't matter if you're using messaging, or it doesn't matter if you already are using event streaming. I'm not saying that one or the other is right or wrong, because in the end, what I really feel is the most important is that you choose what is right for your use case. There's a lot of advantage to having your services communicate in an asynchronous way. But then again, it's also really challenging for surrounding systems to switch from a synchronous to an asynchronous mindset. And I know in my example, I painted like the perfect world where event streaming is really great and it's the perfect solution. But as every other solution, there are also downsides to introducing a new technology. There are a lot of new challenges that you need to face. And I think this is one of the biggest problems. A lot of times we say, this is the new shiny technology and it's a great solution, but I'm being really honest here. I've worked with event-driven service architecture for over 3 years now. And while it's really cool, there are also a lot of challenges that are really interesting, but that you will be facing for your applications. So what I want to say is, maybe you just have a handful of services and you have a really easy, simple, small use case. So maybe you don't need to use messaging. Maybe you don't need to use event streaming and make things overly complicated. But if you see that you are in a company and you have more and more services and data becomes more and more important in your company, maybe then it's worth to have something like messaging or event streaming. Because in the case of Apache Kafka, as I said before, it's really easy to plug in and get the data for other services, even for other departments. Apache Kafka offers, it's called connectors to many different storage systems. So you can have a service that is sending out data to an Apache Kafka topic, and you can use an existing connector of Apache Kafka to store all those events into a database or into an S3 bucket. And the same thing goes the other way around. So maybe you have a database and you want to broadcast all the changes to an Apache Kafka topic. So again, there's a connector for this where you can just plug in your database and it will broadcast all the changes to Apache Kafka. There are a lot of connectors for Twitter, for REST APIs, databases. So yeah. So again, yeah, there's really no right or wrong. It really depends on your use case. And with some time left, that's already it. Thank you very much for joining my track. Thanks again for having me here at this conference. And I think I will see you guys on Discord if you have any questions.